Hello. Okay. So today I'll introduce the third part of our topic, calculus for full. Right? Third part is the part 3, calculus for full. Right? Okay. So now it is actually continuation of our second part and part 2. So just recalling from the part 2, the second part of our topic, we just ended up with 3 formulas of dy over dx and a crucial findings, a crucial rule of dy over dx. We just call it the product rule actually. So the one formula is if y equals x power n, then the dy dx goes to nx power n minus 1. Secondly, if y is some constant in x power n, so the dy dx goes to the constant remains constant and the x power n here, dy dx of x power n equals nx power n minus 1, right? And the third was if y equals some a x power n plus minus some constant b x power n, then our dy dx goes to constant remain constant and the dy dx of x power n equals mx power m minus 1 plus minus b remains constant here and the x power n and then dy dx of x power n equals nx power n minus 1. And a crucial rule, product rule, if y equals u into v, then the dy dx goes to constant u and then dv over dx plus constant v into du over dx. It is a product rule. Okay. Now I will introduce the quotient rule for dy over dx. Right? Okay. The quotient rule. Okay. So I'll erase 1, 2, and 3. I'll erase it. And I'll write here number 4 here. The number 4, if y equals u into v, so the dy dx goes to u into dv over dx plus v into du over dx, right? Okay. So now I will introduce another thing. If y equals x squared plus x squared divided by x cubed, so what will happen? Dy over dx, right? So just one way you can find out. This is very simple. It is a squared, the cube here. So y, you can write it the x squared, and if you bring it the top, the x power minus 3. It is just laws of index, laws of exponents in your class 9 10 syllabus. So it is actually the x power minus 1. So if y equals, this means actually y equals x power minus 1. So if y equals x power minus 1, what will happen? Dy over dx. It is very simple. Minus 1 goes to the coefficients here, is a minus 1, and then x, and the power of x will become the one step lesser from the minus 1. That means minus 1 minus 1. That means is the minus 1 here and is the x power. So minus 1 minus 1 means minus 2. And if you bring it down here, so minus 1 into 1 over x square. That means very simple. Minus 1 by x square. Right? Okay. Okay. So if y equals x square by x cube, then the dy dx goes to minus 1 over x square here. Right? Okay. So the result was minus 1 dy dx goes to minus 1 over x square. Right? Okay. So if I'll introduce x square here, if I take it, x square means u and x cube means v, right? If it is x square, it's x cube, and I'll take x square means u and x cube means v. And obviously, all of you know what is this thing actually. If you introduce the v in the numerator here, it goes u into v to the power minus 1. It's very simple because it's a 1 by v means v to the power minus 1. Okay. Now I will proceed from here. Okay. So what is dy over dx? It is very simple. U is a u into v and that is u into v to the power minus 1. Right? Okay. So what will go? U remains fixed. D dx over v power minus 1 plus v power minus 1 and then du over dx. Okay. Okay. And then all of you know what is this thing actually. It is u into this will goes the coefficient minus 1 v to the power the one step lesser from minus 1, that means minus 1 and I will left out dv dx, right? And it is v power minus 1 into du over dx, right? Okay. So what is this actually? It's a minus 1 into u, that means minus u v power minus 2 dv over dx, right? Oh no, actually is a wrong process. I did it. This is a wrong process. Okay, what is the right process actually? There is a v, right? It is a x, right? It is a v, here is a x. So you should write it dv, and for the correction term you should write dv over dx, right? Because it is a v and it was x, so I will just change it, the coefficients v. So if it is v, then for the correction it will be dv over dx, right? For instance, it is actually here the dv over x, right? But it is actually v to the power minus 1, right? But it is v, it is x. You can't differentiate. You can't find dy over dx, right? So if you change here, so initially there is a dx, and if you change here dv to the power minus 1, there is a dv, and then for the correction you should introduce dv over dx. Then it is a very simple. You can, here is dv and then the numerator is dv, you can cancel out. then you are actually left out here. The numerator here is a d v power minus 1 and then denominator here the dx. It is the same thing, right? So you can, if you have this thing, you can write it. Okay, dv to the power minus 1 is dv and then dv upon dx, right? And I will just write it. Okay. Okay. So here you go. U is actually like a x, right? So it is minus 1 v power minus 1 dv over dx plus v power minus 1 du over dx. What is this? U into minus 1 means minus u. V to the power minus 1 means v to the power minus 2 here. And then du over dx plus v to the power minus 1 du over dx. Oh, sorry, it's a b. Right, it's a b. Okay. So, what's the v to the power minus 2 actually? It is a minus u into 1 by v squared, right? Into dv over dx plus what is this? 1 by v. You can write it v to the power minus 1 by v the du dx. And now, okay, so I will erase some part of our calculations. Okay, so I will do. Okay, here. So it is minus u over v squared dv dx plus 1 by v du over dx, right? Just take the LCM, right? So v squared dx and the very simple minus u dv plus Mr. v du, and if you, it is a dx here is a denominator. If you introduce here numerator, it goes minus u dv plus v du over dx by v squared, right? It is a whole division, a long division, v squared. So we'll just split it up. Minus u, just split it. U dv dx plus v du over dx. So u dv over dx plus v du over dx by v squared, right? Yeah, it is actually our quotient rule for dy over dx. If y equals to u over v, then it is a quotient rule of dy over dx, right? Just look at this calculation. It is very simple. It's nothing into it. Just nothing into it. There is a crucial trick here. Yeah, there is a there was dv to the power minus 1 over dx, but there is x, there is v. So I can't dy over dx. I actually here put dv, and for the correction term I will introduce dv over dx and nothing else. Okay, just very simple. Just it is very simple, right? Okay. So now it is our result. If y equals some minus u, y equals some u by v, some u by v, then the dy dx goes to v squared minus du dv over dx plus v du over dx minus u dv over dx plus v du over dx. Just verify. Now I will verify this thing with our previous results. If u is x squared and v is x cubed, then what will goes dy over dx, right? Okay. So it is our previous results. If y equals x squared over x cubed, the dy dx goes to minus 1 over x squared, right? So now if I'll introduce here right now, it is if y equals u by v, then we'll get a crucial formula or crucial results. Dy dx is actually the whole division and the v squared here down in the denominator, in the numerator here, minus u dv over dx plus v du over dx. Just put it here. So u means x squared and v means x cubed. So what will dy over dx? The v squared means x cubed whole squared, x cubed whole squared, minus u means x squared, so u is x squared, d v means x cubed over dx plus v means x cubed into d over dx. U means here x squared, right? Okay. So ultimately minus x squared into, obviously all of you know what is happened, is a dx cube dx. I mean if y equals x cube, then dy over dx goes to 3x squared plus x cube here, x cube into, and then if y equals x squared here, then dy over dx goes to the 2x, right? The 2x, and then x power 3 whole power 2, that means x power 6. Okay. So it is a minus 1 and 3 goes to minus 3, x squared into x squared goes to x to the power 4 plus the 2 x cube into x to the power 1 goes to 2 into x to the power 4, and then it is a x to the power 6. So what will happen in the numerator? It is a minus 3x to the power 4 plus 2x to the power 4. Is actually minus x to the power 4 is a x to the power 6, and obviously all of the more will happen here. X to the power 6 means x to the power 4 into x squared, and x to the power 4, x to the power 4 cancels out, and you will get minus 1 over x squared. Oh my god, formula is going well. It's a very well formula. It's a very good formula here. If y equals to u by v, then dy over dx is here, right? The same results. See, let's look at this thing, the same result. I'll end up with the same results. Okay. So now, if y equals u over v, then the dy dx goes to our crucial findings. It is a okay. So it is a v squared in the denominator, and the numerator here minus u dv dx plus v du over dx, right? Okay. So it is our fifth, number 5 formula, and number 5 rule. It's a product rule. It's a number 4. It's a quotient rule. It's number 5 here, right? Okay. Now I'll introduce a geometrical interpretation of dy over dx. Okay. Now I'll introduce the geometrical interpretation of dy over dx, right? Okay. Okay. So let me start with the story. Right. The story was actually in my childhood days when I was a child. Okay. So actually I followed a newspaper named Anandabazar Potrika. Probably all of you heard this thing. Anandabazar Potrika. So on that paper, on that newspaper, the last page of that paper, it was a game, right? So the game is actually a task was to figure out a figure, to figure out geometrical figure, or to draw a geometrical figure, or any just figure, to draw a figure by connecting two points, the consecutive 2 points with the straight lines, right? So the game is actually a task is to draw a figure, any type of figure, but the condition was to connecting the consecutive points with the straight lines, right? So like I just demonstrated here, what was that? Actually, if there are some few points, right? Just here. Okay. Just some few points on your. Just draw some points on your page and yeah. Okay. So just connect between two consecutive points with a straight line, right? I'll just connect here. This is a straight line, this is another straight line, this is another straight line, another straight line, another straight line here, another straight line here, another straight line here, another straight line here, another straight line, and then another straight line here. These are okay. So this is another straight line. Okay. So I will draw actually some few straight lines here between two consecutive points. Okay. Actually, it is actually it is probably all of you think it is a lining of face of a cat, right? Okay. So just take it one portion of this drawing. Okay, so I will take in this portion, right? I will take in this portion. Okay. So that is actually the figure should be smooth, right? It is a sharpness there. So the figure should be smooth. I mean, if I draw this portion very precisely, it is probably look like this, right? But here is just 4 points here. 1, 2, 3, 4. Right? These are just 4 points here. 1 here, 2 here, 3 here, and 4 here. And you just connect it with a straight line. Yeah. So it is not a sharp, right? Okay. But if you introduce here another 4 points in between these 4 points, okay, just introduce another 4 points between these 4 points, right? Okay, just introduce another 4 points, yeah, and draw the straight line between two consecutive points. Oh, it is actually probably it is precious from our previous drawing. Right. Previously there is a very big sharpness here. Right here, 1, 2, 3, 4. But it is probably a precision. I mean precise. Okay. But it is not actually. It is not truly precise like this thing. But if you introduce there is the 8 points, right? 1, 2, 3, 4, 5, 6, 7. Oh, there are 7 points. And if you introduce another 7th point here, in between these 7 points, you will probably get more precise from the previous thing. Okay, just introduce here the another 7 points. Okay, and just connects two consecutive points with the straight lines, right? Yeah, it looks like probably it's a precise from the previous one, right? So then still there is a sharpness, right? Still it has a sharpness there. So if you continue the process, actually if you introduce another 14 points here, then another 20 points here, then another 56 points here in between points. So one day you ended up the infinite piece points, right? Infinite piece points. And if you connect two consecutive points with a straight line, so there is an infinite piece straight lines, and hopefully you will get the actual drawing. Okay, because it is just the 4, and then I was introduced here another 4 points, then is a more precise, and then if I was introduced there another 14 points here, it is more and more precise. So if you will introduce here infinite piece points, and if you connect consecutive 2 points with a straight lines, you will get a precise curve, I mean precise diagram, right? So there is actually a very crucial findings. I got a very crucial findings here. What is this? One of these actually a curve, because it is actually a curve, right? It is not a straight line, it's a curve. So actually a curve consists of infinite piece points, and number 2, if you draw straight lines between two consecutive points, so draw straight line between two consecutive points, so you will ended up a curve, right? Curve itself, right? So actually, if there is a curve, that is infinite piece points, and if you connect the two consecutive points with a straight line, you will get the curve itself, right? And in between the two consecutive points, there is a straight line here, right? Okay, these are very crucial findings, right? Okay. So let me introduce here what is the tangent. Tangent at a point on a curve. What is tangent? If I will draw a curve here and if I will ask you just draw a tangent at this point. Okay? So tangent means a straight line which actually touches this curve at these points but not cut. Okay? Just touches this straight line at these points but not cut. Actually a tangent means it touches only one point of this curve. Okay? Just only one point. It touches only one point of this curve. It's like this thing. So it touches only one point of this curve. So it is actually a tangent, right? Okay. Okay. But it is not a tangent actually, right? Because obviously it goes to this point, but it cuts it. It doesn't touch. It just cuts it. But it is a tangent because it touches this curve at this point, right? It just touch. Okay. Now, okay. So if there is a straight line, and if I ask you just draw a tangent at this point of the straight line. So what will you do? So see, if you draw this straight line, it is not a tangent because it cuts that point. So it is not a tangent. If you draw this straight line, it is not a tangent because it cuts this straight line at this point, right? So it is not a tangent. So actually, the tangent of this point, the tangent at this point on the straight line is actually the straight line itself. It is because this line actually just touch the points. It is a tangent, right? And if I'll ask you what is the slope of the tangent or the slope of the tangent at this point, so you'll just, very simple thing, you'll just draw a coordinate system here. Here's a x, here's a y, and here's a point where I check that slope actually. So you will drop a perpendicular from this point on the x-axis and drop a perpendicular straight line from this point, okay, on this straight line. Okay. Now obviously from your class 9 or 10 sense, it is a triangle and the slope at this point means the height over base of this triangle. So if I named it here A, it is B, it is C. So obviously the slope at this point means BC over AB. It is very simple, right? But what happens if there is a curve, not a straight line? What will happen? So let's introduce a curve here. It's the y, it's the x axis, it's the y axis. So just let's introduce a curve here like this thing, right? Okay. So if I ask you to find, to calculate the slope at this point on the curve, so what will you do? So probably we'll proceed from the previous one. You just drop perpendicular from this point on x-axis, and then drop perpendicular from this point on this straight line. Okay. But the problem is that, okay, just name it. This names the coordinates of this point is x, comma y. That means all of you know what is x, comma y. It is actually x and it is actually y, right? Okay. Okay. But the problem is that it is not a straight line, right? It is a curvy line. So it is actually not a triangle. It is not a triangle. If you enlarge it, if you zoom in, you will get this type of diagram, but it is not a triangle. So what will you do? Okay. So if is a base, probably the base is a height. So if you reduce the length of base, okay. So first of all, there was it is, and if you reduce the base, like previously here, so I will reduce the base, and of course we should reduce the height, obviously. So now just instead of the triangle here is not a triangle, it's a curve. The hypotenuse is a curve. So it's not a triangle. But I continuously reducing. Okay? If I continuously reducing the base, so it's the second case. The third case, if I continuously reducing, okay. Now obviously it is not a triangle because it is a curve, but another reducement here, yeah. So one day, probably one day, you will find it is a straight line, because if initially if it was, and then if you reduce the length of base, these points actually comes in that point, comes to that point. So if you reduce the base, this point goes to this. If you reduce much more here, these points comes to very closer to that point, right? And if you continuously reducing, this point goes to closer to closer to closer to that point, right? And one day this point actually goes to two consecutive points here. This point actually fall two consecutive points here, right? It's a very small triangle because these 2 points actually are consecutive points, and from our previous knowledge, if there is 2 consecutive points, actually there is a straight line here. Okay, it is a straight line. So actually one day you will end up the straight line here, and it is a actually what will you do actually just reducing the length of the base, right? It is a very small length, and one day if it gets closer to closer to closer to these points, at this stage it will become the two consecutive points here, and it is, what is this? If it is the x, it is a dx actually, right? It is a very small fraction of x. And what is this actually? If it is y, it is a dy actually. Okay, so it is a triangle. Now if I ask you what is the slope of this, slope at this point on the curve, so now obviously you calculate, just put dy over dx here, because now we will get a triangle here, and the height is dy, the base is dx, so obviously the slope is dy over dx, right? Okay, so actually dy over dx means the slope of a tangent at a point on a curve, right? The slope of tangent at a point on a curve. Okay, okay. So now in the next class I will discuss the relation between our physics and mathematics of dy over dx, I mean slope of tangent, right? Actually, probably all of you know, if there is a displacement time graph, and all of you know the slope of this graph is called velocity, right? It is a velocity. So if it is a y and it is a x, so dy dx means the slope, and if it is x and it is t, so obviously dx over dt goes to the velocity, right? The slope of this displacement time curve, I will call it the velocity, right? And if there is a velocity time curve, all of you know the slope of the velocity time curve from your class 9 or 10 sense. The slope of the velocity time curve is an acceleration. So here is v, here is t, so it is a dv over dt goes to acceleration and slope. Okay, okay. So in the next class I will discuss it elaborately, right? It's a very elaborate. Okay.